Hello students, welcome to ePathshala. This is Dr. V.A. In this module we will be talking about what a Dobby weave is, mechanism and working of Dobby weaves, and a brief this thing about the entire this thing. Okay, so we will start with a brief introduction as to what a Dobby is, what a weave is. Weave is a method of manufacturing woven fabrics by interlacing the warp and the weft yarn at right angles to each other. All weaving machines control the warp threads to create a shed. The function of a shedding mechanism is to make an opening for the shuttle to pass through and to change the warp threads according to the lifting plan for the next pick. This can be accomplished by tappet, Dobby or jacquard shedding mechanism depending on the number of threads the pattern repeats on. Tappet and the Dobby mechanism control the lifts and the heel shafts through which the warp yarn are drawn, whereas the jacquard machine controls the individual warp ends. A brief scope and use of the shedding mechanism. Tappet shedding, in this shedding mechanism, the heeled frames are operated by tappets which are mounted on the bottom shaft or a separate shaft known as a tappet or counter shaft. Each tappet is designed according to for a plain weave repeating on two ends and two picks, two tappets are required and they are usually mounted on the bottom shaft. For all other weaves repeating on more than two picks, the tappets must be mounted on the tappet shaft. Tappet design for a particular design cannot be used for any other design. One of the disadvantages of this type of shedding is the number of tappets that can be conveniently and economically used. It will be up to 8 or maximum 16. So any weave repeating on more than 16 ends and picks require a versatile shedding mechanism such as a Dobby or a jacquard shedding. Dobby shedding. This shedding mechanism is more complex than the tappet shedding system. In Dobby shedding, the heeled frames are operated by jacks and levers. In Dobby looms, more intricate designs can be woven. Dobbies are operated by wooden lags with pegs corresponding to the lifting plan, rotating around the roller above the loom. Punched plastic paper pattern cards are also used in modern Dobbies. Modern Dobbies are controlled via electronic system. Design possibilities are crepe weave, mochlino, honeycomb, double cloth, etc. Dobby looms can conveniently control between 6 to 40 heeled frames. And a brief about the jacquard shedding. In the shedding mechanism, the jacquard selects and lifts the warp ends individually. The shedding mechanism is suitable for large, intricate design patterns where most of the ends in the repeat move independently. There are no heeled frames as in other looms. Jacquards are either mechanical or electronic type, capable of handling over 1200 harness cords, which lift and lower the warp ends. The patterning potential are virtually unlimited. Principles of operation. Dobbies are used to manufacture of complicated weaving patterns beyond the range of tappy shedding mechanism and is at the same time too small to be economically produced by a jacquard. Dobbies are broadly classified as a positive Dobby and a negative Dobby depending on the cycle of the knife movement. Dobbies are further subdivided as single lift, single jack or double lift, double jack. In a single lift Dobby, the knife movement is completed during one revolution of the main shaft, whereas in a double lift Dobby, it is performed during 2 revolutions of the main shaft. Positive Dobby. The heeled frames of a positive Dobby are raised and lowered without the use of a reversing mechanism. These Dobbies are suitable for weaving woolen, worsted and heavy cotton weaving on high-speed looms. Negative Dobby. In a negative Dobby, the heeled frame movement is controlled in one direction, either to raise or to lower the heeled frame. As most Dobbies are mounted on top of the loom, the lifting of the heel shaft is carried out by them and the reversing is done using special reversing motions such as springs or elastics. Negative Dobbies are further classified depending on the nature of shed formed, namely open shed, semi-open shed and closed shed Dobby. We will talk about a positive Dobby. In a positive Dobby shedding motion, the heels are usually pulled and lowered simultaneously to form the upper and the lower shed. As a general rule, while choosing a positive Dobby, the working speed of the loom has to be considered along with the type of fabric. As such, medium and heavyweight fabrics are woven with a positive Dobby. A sectional view of the essential working part of a positive Dobby is represented in Figure 1. The Dobby is suitable for weaving heavyweight woolen and worsted fabrics. Heeled frame top is connected to the upper arm of the jack lever A and the bottom to the lower arm. Each jack lever is connected at the center to a vibrator gear B by means of a connector T. Above and below the central vibrator gear are two cylinders gears C1 and C2. The cylinder gears have teeth cut on them, one half of their circumference, the other half being blank. They are driven in opposite directions as shown by the direction of arrows and rotate continuously, making one revolution every 2 picks. The vibrator gear made of steel discs, which is 4.75 mm thick, and are cut with teeth to match those of the cylinder gears. However, the entire surface of the vibrator gear is not covered with teeth. On one side, a blank space of 1 tooth is left, and diametrically opposite side, a blank space of 3 tooth is left. The vibrator gear rotates freely on a pin named O of the vibrator lever D, which is fulcrumed on the heel pin P. The vibrator lever D, which is raising on the pattern chain E, moves around the pattern cylinder F. The pattern chain consists of small rollers called raisers and links called sinkers. When the pattern chain moves along the pattern cylinder, either a raiser or sinker according to the lifting plan is brought under the vibrator lever. A raiser lifts its respective vibrator lever and brings the vibrator gear in contact with the top cylinder, which is constantly rotating. When the teeth of the two mesh together, the cylinder gear C1 turns the vibrator gear B about half the revolution. That is, until the blank spaces of 3 teeth is brought on the top. This movement of the vibrator gear causes the connector pin Q of the vibrator connector T to move from one dead center to the other, with the result the corresponding heeled frame lifted. The vibrator gear continues to keep the heeled frame raised as long as there is roller under the pattern chain. As soon as the tube comes under the vibrator lever, it brings down the vibrator gear in contact with the bottom cylinder gear C2, and again the vibrator gear turns half the revolution, this time lowering the heeled frame. A steadying pin S, which is part of the vibrator gear, moves in a semicircular slot of a vibrator gear and controls the extent of movement of the gear. Lock knife R locks the vibrator levers in position while the corresponding vibrator gears are in motion. This also prevents the vibrator being forced out of contact with cylinder gears. However, the lock knife is moved out of contact when the pattern chain brings a new pattern below the vibrator lever. So there you can see a cross-sectional view of a positive Dobby with all the illustrations there. Okay. So next we'll go on to the negative Dobby. The essential part of a double lift single jack Dobby mounted on top of a loom are shown in figure 2. They are the heeled lifting jack A fulcrumed at O, balk lever B, which holds the lifting jack A. Then you have the draw hooks C1 and C2, and the knuckle ends of each draw hook is held by the upper and the lower end of the balk lever. Feelers D1 is a straight end feeler, whereas feeler D2 is a curved end feeler. Both the feelers are fulcrumed at D. The back part of the feelers are made heavy so that they remain on top of the wooden pattern cylinder E. The wooden pattern wheel placed beneath the feelers are given 1/8 turn every second pick. To accomplish this, the cylinder is grooved lengthwise to enable the wooden lag to be housed properly during its rotation. The pattern chain F consists of number of lags linked to one other by a chain ring to form a continuous chain to run on the cylinder. Each lag is provided with 2 rows of holes and each represents 1 pick. These lags are pegged using a small wooden peg according to the lifting plan. The needles G rest on the straight edge feelers D1 and support the top draw hook C1, and the bottom draw hook C2 are supported by the curved edge of the feelers D2. Draw knives H1 and H2 extend the full width of the Dobby and reciprocate in the slots of the side frame. Stop bars K1 and K2 also extend the full width of the Dobby. The horizontal arm of the T lever L, shown in figure 3, is connected to the driving rod, which is connected to the bracket of the bottom shaft, whereas the two ends of the vertical arms are connected to draw bolts M1 and M2, as shown in figure 3. So double lift negative Dobbies are of two types, single jack and double jack. With single jack, the disadvantage is getting a straight lift of the heel shaft. Various methods are used to prevent the lateral movement of the heels. The double jack Dobby combines the two jacks by means of a short link called as C link, as shown in figure. The outer jack A is fulcrumed at O1 and controlled by the balk lever B, as with a single jack Dobby A. Short link L couples the outer jack A1 to the inner jack A2 fulcrumed at O2, and both the jacks are lifted together. See the working of the double lift Dobby. When the loom starts working, the T lever swings and reciprocates the knife through draw bolts. And the knife completes one reciprocating movement every 2 picks because they are driven from the bottom shaft. With the movement of the knife, the pattern cylinder with the continuous lag rotates 1/8 of the turn, bringing a lag with pegs and blanks beneath the feeler. A peg in the lag will lower the corresponding hook, which will engage with the draw knife. For instance, consider the straight edge feeler is lowered by a peg on the lag. Then the top draw hook C1 is also lowered to engage with the top knife H1. Similarly, if a curved edge feeler is lowered, the bottom draw hook C2 is lowered to engage with the bottom knife H2. Then the draw hooks C1 and C2 engage with the knife and will be drawn forward along with the balk lever by the knife during the sweep of the T lever. If the top part of the balk lever is pulled forward, the bottom part rests solidly against the stop bar K2. Thus, the stop bars K1 and K2 act as fulcrum for the forward moving balk lever, which in turn lifts the jack lever and the heel frame. However, a blank in the lag would keep the reciprocating drawing hooks raised, but the knife and so the heel frame is not raised. Okay, now in this part we will talk about the extra warp and the extra warp designs, as to what an extra warp design and what an extra warp design is, and how the formation of the figure takes place and how the weaving is brought about. The formation of the figure by means of an extra thread could be accomplished by either an extra warp or an extra weft, or the two methods may be combined in combination. When extra warp is introduced, then a separate warp beam is required for each warp because of the different take-up rates between the ground and the extra thread. The form of the design may render it necessary for the extra threads to be inserted in intermittent or continuous order with the ground threads. The arrangement of the figuring and ground threads may be one figure 1 ground, one figure 2 ground, or one figure 3 grounds, and so on and so forth, according to the solidarity of the structure required. However, an extra weft figuring, the loom must have the capability to insert more than one kind of weft. For looms with draw box or changing box at one end or both ends may be used to produce similar effects. On one by similar effects such as the 1x1, which is also called as a picket will, or by wefting 2 figure and 2 ground picks. The extra warp motif and the ground weave are shown in figure 5 and 6 respectively, whereas the full construction of the extra warp motif with the ground weave introduced is represented in figure 7. The solid marks on the extra end indicate warp up, while the lifts of the ground marks are represented by a cross mark. So you can see in the figure, this is an extra warp small motif which is repeating on 9x6, where the spot mark is the what is going to be an extra warp, and we will be introducing the ground warp in between this spot weave. And the next figure you can see the ground weave, which in this case is we have selected a plain weave which is repeating on 2 ends and 2 picks, but for the sake of representation we have shown it on 4 ends and 4 picks. So in the next construction, you can see here the actual construction of the extra warp designs, where you have the extra thread in one warp beam and the other the ground weave in one warp beam, and you can see the extra and the figuring ground threads arranged in one by one order, where you can see the extra figuring followed by ground weave, then the extra followed by ground, extra followed by ground. So in this way we have arranged it, and there are 2 beams required to manufacture this spot weave. Then we just look into the methods of constructing a square paper, how a square paper or a graph paper is actually. Extra weft figure fabric may be formed by only one series of warp thread along with 1 or 2 or more extra weft picks in addition to the ground weft. The complete structure is shown in figure 10. Methods of constructing a square paper. Extra weft figured fabric may be formed by only one series of warp thread along with 1, 2 or more extra weft picks in addition to the ground weft. The complete structure is shown in figure 10. Figuring picks solid marks arranged on alternate order with ground picks cross marks. In the figure 8 and 10, the design convention has been reversed. That is, the solid marks and cross marks indicate warp down and blank marks warp up. This would help the designer visualize the figure formed on the design paper. So here again in this extra weft design, we have selected the spot weave, which is repeating on 6 ends, and can you go up? And the ground weave, once again we have selected a plain weave, which is repeating on 2 ends and 2 picks. Again, for the sake of representation, we have represented on 4 ends and 4 picks. Now you can see the extra weft figuring constructed with one extra weft followed by a ground weave. So you can see the entire design being constructed on the extra weft mode. So with this, we will go to the next thing as to how to secure the extra ends which have been formed. The methods of securing the extra warp and extra weft threads which have been floating on the back of the fabric. So one of the following methods may be used in securing the extra warp and extra weft threads in the portion of the cloth where they are not required to form the figure. The extra yarn is allowed to loosely float on the back of the cloth, or in some cases the extra yarn is allowed to loosely float on back and it is afterwards cut and removed. That could be another scenario, whereas in the third case the extra warp threads are bound in on the underside of the cloth by stitching threads. So this is by using stitching mechanism where the float lengths are larger, it would be stitched to the underside of the cloth to consolidate the structure. And the one other technique which is being used is the extra threads are interwoven on the face of the cloth in the form of small figures, so thereby consolidating the structure. So I think in this module we have just gone through the basics of what a Dobby weave is, how the Dobbies are classified, and there's just we saw about the figuring techniques as the extra warp and the extra weft techniques. To sum up the learnings of this module, we would just like to brief as to what was totally conducted in this module. So we started with the limitation of the shedding mechanism as to what is the scope of each of the shedding mechanism. We have seen about the tapered shedding, we saw about the Dobby shedding, then followed by the jacquard shedding. And in this module we have elaborated more on the jacquard shedding, the Dobby shedding, wherein we have seen the scope of positive and the negative Dobbies and the limitations of each Dobby. Then we have seen the working mechanism of the positive Dobby as well as a negative Dobby. Then we followed this up with the extra warp and extra weft designing method as to principles used in extra warp and extra weft. What is the number of attachments required? We require an additional beam in case of an extra warp. You require an additional shedding drop box mechanism in case of an extra weft design. So as to how to go about with the development of an extra warp and extra weft design. And lastly, we have just seen as to how to remove the extra threads which have been floating on the back of the fabric, such that it does not interfere in the day-to-day usage of the material. So until next module, see you again. Thank you.